Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. An honor to meet you here. In this opportunity, I would like to present my research about evaluation of growth and biomass production of sorghum on cadmium-contaminated paddy field. But firstly, let me introduce myself. My name is Nur Aziza Uswatun Hasanah. I am doctoral student of 11 Maret University. Ladies and gentlemen, as introduction my research are effort to realize the foodstuff availability which are sufficient and safe for the community through intensification of plant cultivation to obtain high yield has had negative impact. The application of technology, the management of soil and plant that are less precise and tend to be overexploited can reduce physical, chemical, and biological soil fertility. The application of fertilizer and pesticide that exceed the dose to maintain and increase crop yield cause the concentration of several types of heavy metal in soil, water, and plant to increase beyond the permissible threshold. In other hand, increased industrialization and urbanization have contaminated soil with heavy metals. Disposal of industrial waste into water that are used for agricultural irrigation worsen heavy metal contamination in paddy field, increasing concentration of heavy metal in water, soil, plant, and crop products. It causes serious environmental problems for modern agriculture and human health. Cadmium is a non-essential element that is easily absorbed by plants, including one of the toxic heavy metals that causes pollution of paddy field. Its accumulation in the soil poses the threat to agroecosystems and human health. The toxicity of cadmium needs to be controlled by degrading, absorbing, or making cadmium contaminant in soil or water harmless to plant, animal, or human by using plant or what is known as phytoremediation technology. Phytoremediation is the use of plants to restore contaminated soil and water resources by mechanism through a single or combined process of phytoaccumulation, phytostabilization, phytodegradation, phytovolatilization, and hydraulic control. And sorghum is a versatile C4 plant with widely expandable end product, including grain, forages, syrup, beverages, sugars, and cellulose bioethanol. Sorghum has an adaptive capacity to grow in various environments, has high photosynthetic efficiency, has water and fertilizer efficiency, resists to pests, drought, salinity, and alkaline soil. Sorghum has the best carbon assimilated rate. They are attracting a lot of attention of attractive candidate for soil phytoremediation. Based on the description above, the aim of this study was to obtain potential sorghum varieties for cadmium phytoremediation by assessing the growth and the capacity of sorghum biomass in paddy fields contaminated with cadmium. Material and methods. The research was conducted from March to June 2020 in paddy field on Balicatur, Gamping, Sleman, Yogyakarta. Experiment was carried out using a single factor treatment ran in the completely randomized block design. The treatment given as variety Super 1, Samurai 1, Suri 3, Numbu, Kawali, and Hitam. The description of varieties as in the table 1. Research preparation. The land used in the research was processed manually. Before using the land, soil samples were taken and analyzed. Analyzing result on the table 2. The planting of sorghum was carried out by making hole with a space 20 cm in line, while the distance between in line was 16 cm. Its hole was planted with 2 until 3 sorghum seeds with a planting tip 5 cm. Fertilization used chemical fertilizer. Fertilizer was applied twice at the age of 2 weeks after planting and 6 weeks after planting. Maintenance included irrigation, pest control, and weed control. The parameter measured included agronomic parameter, plant height, chlorophyll content, plant growth analysis, plant fresh weight was measured from the production of sorghum consisting of stems, leaves, and panicle. Analysis of data obtained were analyzing using analysis of variant or ANOVA with significancy level of alpha 5%. Further tests will be carried out using Duncan multiple rank test at a significance level of alpha 5% for data with significancy differences between treatment. Result and discussion. The land used in this study was technically irrigated agricultural land with rice crop throughout the season. Soil samples were taken from ex-rice paddy field, then analyzed for several metal elements. The results are presented on Table 2. Critical limit classification of available metal in the soil according to Ministry of State for Population and Environment of Indonesia and Dalhousie University, Canada. Available of element: chromium 2.5 ppm, copper 60 to 125 ppm, cadmium 0.50 ppm, lead 100 ppm, and zinc 70 ppm. These criteria data were used as comparison to result of soil sample analysis in this study. Next is parameter 1. Plant height. Plant height is one of the research parameters to determine how plant grows. The average plant height during the study is presented in Figure 1. Plant increase in height with time. At the beginning of the vegetative growth phase or 2 weeks after planting, the variety Super 1, Suri 3, and Numbu had the highest plant height. However, at 6 weeks after planting until the end of the vegetative phase, variety Super 1, Samurai 1, and Kawali showed the highest plant height compared to Suri 3, Numbu, and Hitam. This was presupposable because each different variety had different genetic abilities. Each variety of sorghum responds differently to the environment. Meliala 2020 cited that the growing potential of sorghum is influenced by the genetic characteristics of the variety, climatic condition, and the environment in which it grows and its cultivation practices. The results of that Super 1, Samurai 1, and Kawali varieties had a plant height of more than 2 meters, which was significantly different from Hitam varieties. Meanwhile, Suri-3, and Numbu varieties are classified as having medium plant height. The average plant height of Suri-3, Numbu, and Hitam varieties was lower than varieties description. The three varieties showed suppressed growth with cadmium contaminant in the paddy field, 2.91 ppm. Meanwhile, Super 1, Samurai 1, and Kawali varieties show higher plant height. 2. Chlorophyll content. Chlorophyll is a determining element of plant photosynthetic ability, which is mostly found in plant leaves. Leaf chlorophyll levels are closely related to the greenish color of the leaves. Chlorophyll content in Super 1, Samurai 1, and Kawali varieties show the highest level and was significantly different from Hitam varieties. 3. Specific leaf weight. Specific leaf weight contains information about leaf thickness. The higher of specific leaf weight, the higher of leaf thickness. Leaf thickness indicates the amount of photosynthetic organelle in the leaf. Based on Table 4, Samurai 1 variety showed the largest leaf specific weight and was significantly different from Super 1, Suri 3, Numbu, Kawali, and Hitam varieties. The high leaf thickness in Samurai 1 supported the high growth rate of Samurai 1 variety. 4. Leaf area index. Leaves are the main component of plants which have the main function as the place to carry out the photosynthesis process. Leaf area index shows the capacity of plant in the process of photosynthesis carbon assimilation as an estimate of plant growth potential and determines plant biomass production. Samurai 1 shows the highest leaf area index and was significantly different from Super 1, Suri 3, Numbu, and Hitam. However, the Samurai 1 is not significantly different from Kawali. Net assimilation rate. Net assimilation rate is the ability to produce 3 meter per leaf area per unit time. The net assimilation rate is used as measure of the plant photosynthetic rate after subtracting respiration. The net assimilation rate describes the plant's ability to produce biomass per unit leaf area per unit time. Although the leaf area index and specific leaf weight were high in the Samurai 1, the net assimilation rate for the Samurai 1 variety was the same and not significantly different from the Super 1, Suri 3, Numbu, Kawali, and Hitam. The net assimilation rate will decrease on ontogenic with plant age. Finally, my conclusion. In general, the planted sorghum varieties were able to grow in paddy field contaminated with cadmium. Cadmium contamination 2.91 ppm affected the growth of Suri 3 and Hitam. The tolerant variety were shown by the Samurai 1 that was showed higher value and expressed better growth than the Super 1, Numbu, and Kawali. Varieties that were able to produce large plant biomass were shown by Super 1, Samurai 1, Numbu, and Kawali varieties. The growth and production of biomass, especially plant height and fresh biomass production, were shown by Samurai 1, Kawali, and Super 1. These three varieties can be used as a reference to test the sorghum ability to absorb and accumulate cadmium in plant origin. Ladies and gentlemen, thank you very much for your great attention. Wassalamualaikum warahmatullahi wabarakatuh.